I saw that some of them were actually quite deep in terms of technical details. This is not going to be one of those. This is going to be something more like a big picture business kind of talk. Okay, so if you're here as a techie, engineer, computer scientist, or a practitioner looking to learn more stuff from me at this point, you might be disappointed if you're looking for technical kind of information. But this might be appropriate for people like business analysts, managers, entrepreneurs who are thinking of getting into the data space, trying to do something in that space. Okay, so that is to set the expectations up of the talk. All right. Bunch of questions: how, what, why, who, when, where, etc., etc. I'll try to answer those things. That will be the flow of the talk. Okay, so let's start with data analytics. Why? The reasons behind its prominence these days. Okay, why is it so popular? Okay, so I used to teach a course called Analytics Foundation a couple of years ago, and that is basically the introductory course in data analytics. At that point, I used to tell my students that analytics is going to be the practical and necessary skills for business careers. Okay, and that really, I think, is true. In the last couple of decades, actually, okay, maybe three, starting in the 90s or so, computer literacy was demanded of a job candidate. If you're looking for an employment in the 90s or early 2000s, then you would be expected to be able to work with a computer, like, you know, Office suite, Word, Excel, email, web, etc. That is basically computer literacy, not the ability to actually program a computer, do sophisticated things with a computer, but be able to work with a computer. That was expected of you, still is. But I think very soon, in the next couple of decades, people might be looking for not just computer literacy, but analytics literacy. That is my expectation. I think that tomorrow, that future is already here. Okay. So if you look at my university, like I told you, there are 6 different schools. Each school is starting their own versions of analytics courses, basically because they expect it to pervade all fields of management, business, etc., etc. So that is how it is looking. So it's the right time to be in the field, analytics field. Okay. So, but why is it happening? What are the drivers behind this trend? Okay, so that's what I want to look at. So that will bring me to what I call the mega trends in the data landscape. Okay, let's take a look at that one. So there's the first mega trend that I see, or that not just me, everybody sees, is the volume and variety of the data that is coming into the ocean of data that we have all around us. Okay, the second one is from the demand side. The first one is actually the supply of data. The second one is the pull factor, the demand of data, how data is being consumed. That also is increasing dramatically. Not only that, the demand on data-driven insights generation, the speed with which they have to be generated, is also increasing dramatically. That is about the data velocity. Okay, and underpinning all these things, supporting all these things, are the changes or improvements in technology. So these are the different things that we have to be aware of. Okay, so let me put those things in perspective. The first one, there is a real veritable explosion of data these days that I don't have to tell you, everybody knows this. Okay, so exponential growth in data volume in many fields, and this is expected to continue. Okay, I'll actually quantify this statement in the next slide, and I'll show you different sources. Not only that, there are requirements, analytical and reporting requirements, periodic and even real-time requirements. Okay, and the demand is getting more and more sophisticated. It's not just a batch report that they want. They want in-depth analysis of stress tests, etc., generated in real time. Okay, coming from not just regulators, but also even from customers, especially when the customers are other businesses, right? Okay, the next aspect of this, the mega trend, is actually the velocity, the need for real-time responses in insights that are being generated. Okay, So that is the next aspect. Last one, there are innovations happening, not just on the hardware side, but also on the software side. That is actually supporting all these all these three different pillars of data landscape, and that is something that we have to kind of understand. Okay, I'm going to talk about these things not merely because these things are interesting by themselves in their own right, but also because you might see opportunities when you listen to these things. You might see, that sounds like a place where I might be able to make my mark and do something special. So that's what I'm hoping to get you to achieve or think about at least. Okay, so let's talk about the explosion in data. Okay, there are data streams coming in from sensor devices, connected devices. Okay, Internet of Things, device monitoring, health monitoring, even your phone. Of course, it is a sensor. Actually, it's a multifaceted sensor, and giving you a lot of data coming into the ocean of data that is all around us. Okay. On top of that, you have enterprise data from things like transactional point of sale data, CRM, call centers. With the call center, voice data can be translated to text. Okay. Then diagnostic data, quality control, etc., etc. That's another stream. Then you have data providers, especially in the context of banking. You will see data streams coming in with all kinds of indices, their real-time prices, etc. Bloomberg's, Reuters, Thomson, and there are indexed search providers, specialized search providers. If you're doing something in the IP space, intellectual property space, LexisNexis is one, Credit, Equifax, etc., etc. Then, of course, there are data providers on the government side too. They also generate huge amounts of data. Statistics, stat board in Singapore, for instance. Okay, and those are all just the tip of the iceberg. The real data actually comes from the data that can be scraped from websites. Okay, social media. People put all kinds of stuff on Facebook, LinkedIn, etc., etc., and Twitter these days. You know what's happening in the US with the president, right? Okay, and search engines also have data being generated. Okay, now there are worrying data sources, browser history, weblogs like blogs, my own blog. There's this comedian called Bill Barr. In one of his shows, he said something like, if you look at Facebook, you see somebody's profile. That's what he wants you to see. That is his projection of his personality that he wants you to see. But if you really want to know a person, don't look at Facebook, look at his browser history. A crazy thought, but that is really true. Okay, so that is semi-structured data, maybe, RSS feeds, XML, HTML, etc. But then there are streams of unstructured data also coming in. Instagram, YouTube, video, etc. And now TikTok, all kinds of stuff, right? And that is again only the tip of the iceberg. But if you quantify it, if I want to quantify it, in 2005, the data, the total volume of data in the world was 0.13 zettabyte. 0.13 zettabyte. In 2020, that actually became 44 zettabyte. 44 zettabyte. Zettabyte is actually 1000 exabyte, and exabyte is 1000 petabyte, and a petabyte is 1000 terabytes, etc., etc. So if you want to actually compute the year-on-year growth rate, if you remember your high school logarithm, etc., etc., you can sit down and calculate, which I actually did. It is 47%. Okay, 47% yearly growth. Yearly growth. Every year it's growing almost by 50%, which is huge. But that again is only the tip of the iceberg, because the next stream is going to come from 5G, when devices start talking to each other. Not just people talking to devices or to each other, but actually devices having their own world of communication. That is where the real growth in data is going to happen. So are there opportunities there for businesses, new business ideas? There must be. Your imagination is the only limit there. All right. How are we doing so far? All good? Voice is okay. So that was the first aspect, the supply side of data, where the data is coming from, why there is so much of it. So you got some glimpse of it. The number I want you to take away from it is that 47% growth rate, okay, with no end in sight. It's going to go on like that. Now the demand side, the pull side, the other one was, number one was the push side. This is the pull side of data. That would be the demand for data-driven insights, okay. So look at many different fields. Service improvements, for instance. Chevron, in the space of oil and gas exploration and production, they use real-time data coming from their drilling bits and machinery to improve the efficiency and reduce failures. So that is service improvement based on data, which did not or could not have existed some time ago. Okay. So a completely different sector, hospitality, Disney World, Disneyland, etc., etc., etc. They track customers in their amusement park to optimize the usage of their area. So that's another thing. So what I want you to see is the disparity between the fields. One is oil and gas, totally a completely different field compared to hospitality, which is a service sector, manufacturing and service. Now looking at process improvements, Amazon, a leader in data-driven technologies and utilizations. So e-commerce, of course, they have personalized high margin suggestions. That of course comes from something called market basket analysis, a topic I used to teach in my analytics foundations course. Okay, actually we'll touch upon it later today also. Walmart, retail, and they are optimizing their revenue per square footage in conjunction with their CPG partners, consumer packaged goods partners, so that their supply chain can be optimized. When they run out of something, the demand can be predicted and it can be filled even before they actually have to manually do this. So that is in the retail sector, e-commerce, retail, process improvements. Okay, now there are other things. Existing business like auto insurance. There is a company called Progressive, and this is for auto insurance, car insurance, and they told their customers that if you are willing to put a device capturing your driving patterns, a sensor device capturing your driving patterns in real time, we will give you a discount. On top of that, we will be able to price your premium competitively. So think about that. So auto premiums, already different for different age groups, etc., etc., is getting more personalized. So it's a new product offering, and it's actually even more than that. If you think about it, what is insurance? Insurance is the idea that you can collect risk from multiple sources, you can pool them together, and then give everybody the same premium, so that if somebody actually hits the risk, a 1% event, that can be covered by the pool of premiums that you have. So that is the kind of the risk management idea behind insurance. But if you are beginning to price each person individually, look at the limit, the mathematical limit, the asymptotic level of that idea. What's going to happen? I'm a fairly experienced driver. I've been driving for, 30 years or so. So my insurance is fairly low. My son is probably going to start driving in a year or two. Obviously, he's young, full of testosterone and hormones. He's going to go mad maxing all around Singapore. Obviously, his insurance will be high. But if they actually measure his driving patterns and give him the exact right amount of insurance appropriate to his risk, what does that mean? It means that if he makes an accident, the premium that he pays will be just enough to cover that accident plus the margin. So that is almost like having no insurance at all, right? So the whole idea, the philosophical idea behind insurance also is going away by some of these new offerings. Interesting to think about. But yeah, bear with me. I go on to some philosophical tangents once in a while. Anyway, coming back to the talk, entertainment field, streaming services like Netflix, they can use the history and make informed and optimized investment decisions, okay, for content creation. That is another thing. So those are new product offerings of potentially existing businesses. But there are brand new business models also coming about because of the prevalence of data and the tools that we have to handle data. So there is a company, again insurance, health insurance this time, called Humana, and they use predictive kind of analytics on a person's health parameters and indicators to reduce the healthcare cost. Actually, I also started a company to do something along these lines about 4 or 5 years ago. It did not get anywhere, but the idea was kind of similar. What we were trying to do was to take the health indicators of the body, sensor data, also the medical history, family history, etc., and then make informed decisions and tell the customer or the user to go see a doctor because you're likely to have a heart attack, or your insulin level or your diabetes is probably going to be high, so go and see a doctor now. The idea is that preventive kind of medicine will be cheaper than what is it called, interceptive kind of medicine, right? If you have to actually do curative kind of treatment, that is much more expensive than preventive kind of treatment. So that was the idea. That is what Human also is trying to do, obviously more successfully than I could do, or we could do. And now Nike also getting into that, and there's things like Fitbit and even Apple Watch, etc., bracelet to track athletic activities. Okay. The interesting thing is Nike is actually an apparel company. The sector is apparel. And then they're getting into something that is completely different because of the prevalence and existence of data-driven technologies, data-driven tools, and data-driven technologies. So that is the demand side of data. So that we covered two of them. Now let's cover another interesting aspect of data. Okay. This is about the velocity expectation, the speed. Okay, that is quite interesting. If you have used things like Google Maps, etc., you demand information in real time. If you're driving somewhere and you want to know if there's a traffic jam, it is not good enough if you are told 5 minutes or 10 minutes later. You want to know the information now so that you can take a detour or whatever. Actually, I use Google Maps quite a bit for some personal reasons. I used to go to Jakarta quite often till COVID struck, and from the airport, the place I want to go to, a hotel downtown, is about an hour plus depending on the traffic conditions. And I use Google Maps to see if there is a traffic jam coming up, and it's amazingly accurate. And now that got me thinking, how do they get the data? Where do you think they're getting the data from? Do you think they have satellites or cameras monitoring the traffic and then making decisions based on that? No, it's not that. It's actually something much smarter. When you're using Google Maps, you are also providing data. You're consuming data, at the same time you're providing data back to them. So they know how fast you're going, they know how fast the people in front of you are going, and then they know if there is a traffic jam depending on the speed differential. That is very smart, and there is no way to use Google Maps without giving them the data. Even if you don't want to give them the data, then if you don't want to give them the data, you cannot use it because the app does need to know where you are, right? So that's an interesting dichotomy of consumption and provision of data at the same time. Okay. But the thing is, the expectation of the results, the insights coming out of data is instantaneous, is real time. Okay. Then the IoT in consumer packaged goods, there's this device called Amazon Dash. I've never seen it, but I'm told this exists. This can track different things that you need. If you put it on your milk or Bounty or kitchen towel, when you're about to run out, it knows that you're running out, and it knows from your usage pattern how much you would need, and it takes it upon itself to actually order it from Amazon without you doing anything. And in the US, Amazon delivery time is like 2 hours, and 2 hours later the stuff comes to your doorstep, the money is taken out to your account, everybody is happy. Okay, so that is another instantaneous, near real-time kind of performance in driven by data. Okay. Now another field where dynamic pricing, not just in insurance, it's also airline pricing, and that also they demand near real-time performance in consumer spending patterns and how many people are planning to go to a city, and based on that they can change their pricing. Dynamic pricing, a big money maker for airline companies, again, until this COVID-19 situation. Okay. In logistics, in workflows, Amazon robotics also is a big player. Okay. Order fulfillment efficiency, etc., using their own robotics. If you look at it, Amazon, as you can see, is a big player in this space. And if you look at the profitability and the stock market prices of different companies happening during this COVID crisis, you can see that Amazon is doing extremely well. Why? Because of these innovations based on data. So that is important, and it is really a tool for business revival in these trying times that we're living through. Okay. Now that the third one was the velocity expectation. Now let's move on to why all these things became possible. That is the technology evolutions. Okay. Storage is cheaper than ever. Okay. And so if you look at the cost, it is going down by about 23%. If you again do the logarithmic calculation on that one, that is about 23%. But remember, data is going up at the rate of 47%, twice as fast. So maybe the price is not coming down fast enough. Okay. But that is on the hardware side. And on the software side, there are the distributed file systems necessary for things like big data, where data cannot reside on one computer, and it needs distributed computing for processing and as well as aggregation of results, etc. So there's Hadoop and other streaming architecture like Elasticsearch, Kafka, etc. And cloud solutions, Microsoft there, Amazon again, web services, and on top of all that, free software, Python and R, Apache, Spark. All these things are actually driving the consumption side of data and also the storage side of data. So everything is coming together at this point in time to make the data revolution a reality. Okay. So it's in this context that I want to talk a little bit about big data. So when I started my computing career, maybe some 30 years ago or so, things were basically, data sizes were megabytes, and they were kept in CSV files, text files, some, my own data formats, handled by batch jobs that I would run when I need to. And then it became something more structured, where data started residing in databases. By the time I reached the bank, it was that way. And there would be periodic kind of jobs, and the data ran into gigabytes and terabytes. That's the evolution that happened. And later, data started to be in social media and streaming services, etc. Images, audio, video, well, audio at least. And the performance needed to be near real time. Okay, when you upload something on Facebook, you don't want to be waiting for a couple of days before that appears, right? And the data started becoming into terabyte and petabyte range. Okay. Then once the media started kicking in, YouTube, TikTok, and streaming services like Netflix, Amazon Prime, even Apple TV Plus, etc., etc., and mobile data, of course, the data became exabytes. That's where we are. Okay. Now, where are we heading? In, I think, a very short span of time, you will start seeing massive device-to-device communication and creating data lakes with this advent of 5G, ultra-low latency kind of infrastructure, and data is going to be in the zettabyte range. So data volume is going to grow tremendously, supported by technology innovations. Okay, and the performance in terms of the velocity requirement expectation will be supported by Moore's law, the computing improvements, and data variety also is going to grow exponentially. It is this structure that we mean by the big data. So big data basically is unstructured data, not residing in any kind of databases, unstructured, hard to handle, huge, so that you cannot load it into the memory of one computer. It has to be on multiple computers. Then you need ways in which you can do things in parallel and then aggregate results, okay, and insights. So that is my one slide about big data. Okay, so we saw the why of data analytics, why it is important, and how it came to be. Now let's look at what it is. What is data analytics? It's the process of turning data into action from a business perspective. So data is a large volume of stuff. The information density, the density of knowledge in data is fairly low. It is spread out. Then you do some kind of processing. Then you go up the pyramid. You kind of distill information out of it. Okay. And at that point, you need quite a bit of expertise in data handling. Okay. And the tools are Python, what have you. And then you move on from there to more distilled or condensed form. That would be insights, added depth in the knowledge or information. Then the skill set actually moves from a technical skill set to a business knowledge kind of skill set. So that is important to know. That is important to realize. When the value of information becomes more condensed and more acute, that is when the business knowledge, the domain knowledge becomes important. Domain as in not the technical domain, but the domain in which you are operating, your core competency domain. Okay. And finally, when it comes to recommendations, that has to be translated to a business solution. So you start with a business problem, you end up with a business solution that has to be translated to a business solution. Only then can it be translated into an action. So that is the value pyramid, and it is in this context that you have to kind of focus on your ability to communicate, understand business problems to begin with, translate that into technical problems, and then in the end translate it back into a business action, business decision, business recommendation. That is what I mean by communication in this domain. Not really the language skills or the ability to make presentations, etc., but to be able to translate, go from the technical domain to the business domain. All right. So with that, let's look at the skill set that is needed for a data scientist. Okay. Love of math, understanding of statistics, Excel maybe, or some other thing like Tableau or whatever, and an affinity and a facility with large data sets, and exposure to data mining techniques. And then I have highlighted in red here, business domain knowledge. That is something that we tend to kind of ignore. If you go on YouTube and look for any kind of data science or data analytics kind of topic, you will see that a large number of videos are actually by Indian instructors. And I'm sure there are an equally large number of videos by Chinese too, but they're probably speaking Mandarin, so we probably don't get to see it. What I'm trying to say is that there is a depth of a technical knowledge in both these countries, India in particular, and maybe in China as well. But they don't seem to succeed that well when it comes to going up the corporate ladder, probably because the inability to appreciate the need for the business domain knowledge and the ability to communicate technical solutions to the business domain. Okay, so I'm going to harp on that a couple of more times to drive that home. Okay. All right, so harping on it once more right here, communication skills to present the technical solution as a simple business recommendation is what is needed. Okay, so there are different skill sets that you need. I talked about the need for communication, but what if you have only communication skills and nothing else? Then you're basically hot air. There's nothing else you can do there. Okay, but if you add something like statistics, a mathematical technical skill to that, okay, then what you get is if you have only statistical skills, then that would be a data kind of guy, a data nerd. But if you have both statistics and communication skills, then you become a stats professor. Not totally unlike myself here, actually. Then if you add to that programming skills, if you have only programming skills, then you're a hacker. But if you add statistics to it, then you become R programming or Python programming kind of guy. Okay. And if you add communication skills, then you become a consultant. Then you're beginning to add value. And if you have communication skills and programming, then you're probably a computer science professor. Again, not totally unlike myself. I actually do teach a computer science course, but a math course, linear algebra for computer science. All right. Then if you add business, that is when everything starts to come together. If you have only business knowledge, again, you are just an accountant. But if you add programming, then you become the IT guy. And if you add statistics too, then you begin to be something like a data scientist wannabe. Okay. But if you have all the 4 skills, then you are a perfect data scientist. So that is where you want to be if you want to be a data scientist. But this talk is not really targeted at those people because I don't have the technical details that I'm sharing with you in this short webinar. So if you want to be a data scientist, then you will have to start taking my courses at SMU. But I'm targeting people with all skills other than programming. That would be a perfect business analyst. And those are the people who might benefit best from my talk today. Okay, there's a business question, a business problem that you have to solve. Then based on that, you come up with some data analysis plan or data collection plan, and then you activate that. You do the collection of data or maybe find data that is already there. Then from 3, data collection, when you have data, you derive insights. And after that, you come back to the business domain with your recommendations. So in 3 and 4, you're working with data. In 5, you're back in the business domain. And there, if you start talking about data and the properties of statistical properties of data, you have lost the business people. So there, you have to be careful. Your job as a data analyst will actually be between the data collection part and deriving insights part. So you have the data, you need to derive insights. That's where data analytics comes in. So it's a small part in this value chain, in this process flow. And the most important skill, even though the sexy part of data analytics would be the algorithms, the programs, etc., it's actually elsewhere. Okay, it's actually elsewhere, the value. So that is something to keep in mind. Communication is the key. So the little vertical arrow that I showed there as data analytics in the previous value chain can be expanded from a practitioner's perspective, from a data scientist perspective. So you have 4 distinct steps in a data science project or data analytics project. There's EDA, exploratory data analysis, then the data preparation, then the model development, and finally understanding the output of the model. For the vertical arrow that I showed in the last barrier paradigm, where I said data analytics, that is divided into 4 sections. And again, the sexy part would be the third one, the model development. That is where everybody wants to be. Some kind of algorithm, fancy algorithms, new, convoluted neural networks, deep learning, whatever. That's what you want to be doing. But that is only a smart part, only a very small part. If you look at this, the time spent on this, 80% of the time will be spent on EDA and data preparation, and maybe 10%, 15% in actually running the model, even developing the programs, and then the rest of it will be in interpreting and generating insights that are amenable or digestible to the external world. Okay, keep that in mind. Don't lose perspective of the whole business problem. Don't just focus on the technical expertise. That is my message. Now, I know that I'm saying this over and over again because I teach in a management university. So that is our focus. So if you're actually doing this in a computer science class, it might be completely different. So we talked about the why and the what, I believe. Now let's look at some little bit of details. How do you classify analytics into different categories based on the method and purpose of what it is that you're trying to do? So analytics can be classified into descriptive analytics, which is like dashboarding. You want to know what's happening right now. So monitoring, if you're running a call center, for instance, you want to know how many calls are coming in, how long each person is taking, and is it increasing? Well, maybe not even that. It's just what's happening right now. Monitoring, dashboarding, that would be descriptive. Then the predictive side would be based on what you know from the history, what happens in the future, what will happen in the future. That will be predictive. And that would be some kind of regression analysis, auto regression, something like that. And then there is prescriptive analytics, which is kind of more interesting and more value added, whereby knowing what's happening and knowing what's likely to happen, you take action. Actions are prescribed to you by the analytics engine so that you can influence the future. So that is kind of the different ways in which you can classify analytics. But that is by method and purpose. So it's from a business perspective. Okay. But from a technical perspective, from the side of algorithms, there are two kinds of algorithms: unsupervised and supervised tools. Okay. So unsupervised would be pattern discovery. Supervised would be pattern recognition or pattern learning patterns. Okay. So unsupervised, the question is, do we have pattern? I have a lot of data. Does it have any pattern? I don't know, but tell me. So that is what the program will tell you. The algorithm will tell you. It's pattern discovery. So unsupervised means there are no labels to the data points that you have. There are no annotations. Okay. So if you have a retail shop and you have a large number of customers, let's say you have 1,000 customers, you have their spending patterns, etc. in the database, but you don't know what it is that you can use, what it is that you can derive or learn out of the data set. That would be a pattern discovery. You might be able to cluster customers into 3 or 4 different groups to have targeted marketing campaigns, for instance. Okay. Another thing is if you have transactional data, lots of people buying and buying different things in different baskets, you can derive information about what it is that people are likely to buy together. That would be market basket analysis. Okay. Those are both data with no labels, no annotations, but discovering patterns. But the second one is about you have the data, you know the pattern, but can a computer use it? That would be pattern recognition or learning. Okay. That is supervised in a sense. You already know the patterns, so you can label the data. So I'll illustrate it using an example very soon. Okay, so this will be things like face recognition. You give a large number of photos of one person to the computer, or many people to the computer, and then you give a new photo to the computer and can recognize whose face it is. Okay, so face recognition, classification, decision support. Okay, regression for kind of time series analysis for prediction. All those things will fall under that category. Okay. So let's look at clustering algorithm. Suppose I give a bunch of photos to a computer, photos of animals actually, to a computer. Okay. So I have this as an animated screen. I hope it comes through. Okay. And then you tell the computer that you have 2 kinds of animals. Can the computer actually put them in 2 sensible groups so that the animals are segregated? Okay, without your help, without any further help. But you do have to tell them that there are 2 kinds of animals. Tell the computer that there are 2 kinds of animals. Beyond that, there is nothing else. Okay, so computer may not be able to do this perfectly, but a child, if you ask your 5-year-old to do this, he or she will be able to do it. This is about pattern discovery. Okay, so the keywords here will be clustering. There are algorithms like k-means clustering, hierarchical clustering algorithms, etc., etc. Okay. So it's useful in things like grouping customers, uncovering hidden patterns, etc. So the next slide is animated. Hopefully you can see this. So you have one photo, the second photo, horse, tiger, horse, tiger, bunch of horses, tiger. So we give these photos to a computer, okay, in some sensible format, and ask computer that tell the computer that there are 2 kinds of animals here. Can the computer put them in 2 groups? So a computer can indeed do it by using something like k-means algorithm, not specifically in this image recognition problem, but in if you have data sets, if tigers and horses were actually data points, then it would create 2 sets of points, group them together, have something like a bisecting boundary between them, etc., etc. Okay, so this can be done. So that will be clustering. But if you go to Amazon and buy a book, for instance, something like by David Nichols, if you haven't read David Nichols, I would highly recommend it. Very good writer. 20 or 30 years from now, you will be hearing about him rather than other people. I think, my guess. So I have read quite a few of his. So if I wanted to buy this one day, Amazon will come and tell me that there is this book called Us, Starter for 10, The Understudy, etc., etc., by the same author. How does Amazon know that I would be interested in these things? It's not so much that it's by the same author. It's because Amazon knows that somebody who bought one day has already bought other books in the past. So I'm likely to do the same thing. Okay, so that is a cross-selling opportunity. Okay, so a cartoon here is if you buy something, customers who bought bananas also bought carrots, etc., etc. So there's a cartoon. Okay, so that is market basket analysis. So it's also called association mining. Now that is unsupervised learning. Now supervised learning will be about things like churn models, face recognition, fingerprint recognition, etc. So suppose I have data, again the same kind of data that I had before, tigers and horses. Okay, so let's go over to classification, which is a supervised learning technique. So suppose you have pictures of different animals. At the same time, you have the label or the name of the animal whose picture it is. Okay, suppose you have that. So you have a tiger with a tiger label, horses with horse label, tiger, 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 tiger again, a horse label, etc. So basically you have pictures along with its labels. And if you have that, can a computer learn the pattern and then use it? That is pattern recognition. That is supervised learning. It's called supervised because somebody supervised the photos and attached labels or annotations to it. Okay, so you have the data and then you have the label. So the label becomes another column in the data table technically. Now if you come back to the system and give it a new photo that the computer hasn't seen and then ask the question, what is it? Is it a tiger or is it a horse? It will be able to tell you almost certainly every single time. But that is interesting. But suppose you give a different photo. Suppose you give that photo. What do you think it's going to tell you? I haven't done this, but I would think that it's going to tell you that it's a tiger because it has only it knows only tigers or horses. So this is going to be closer to a tiger than a horse. And the other guy, which is a donkey, will be tagged as a horse because it's closer to a horse, same family or whatever. So it's not perfect in some sense. You have to be careful about the business context in which you're operating this. But if you know that you have only tigers and horses, then this program is a good one. So business applications of classification kind of algorithms would be loan approval. Suppose you have, again, I'm talking from the perspective of a bank. Suppose you want to approve a loan, you have parameters, the data from the customer, from the other loans or other instruments that the person owns, external data, credit rating, etc. And then you can come up with one classification, one flag, okay, yes or no. So how does it work? You have a large amount of data. People have already approved or rejected loans before. So you can say that, okay, these data points, they got rejected. These data points, they got accepted. So that would become the training data. You throw it to a computer, ask it to learn the pattern without really telling you what the pattern is and how much weightage went into different components, etc., etc. You just let the computer learn it, and then you give a new customer the same kind of data, and the bank will come back to you and tell you it's good or bad to give a loan to this customer. Okay, again, without telling you how it is actually doing it in most cases. All right. So I'm pretty sure this is actually being done in the bank already. I don't think approvals are actually done by hand anymore. But there is another thing called counterparty credit risk management. This is something I had some exposure to when I was in the bank. And this was usually done using credit limits or credit ratings. And I think it's still done that way. But can you take the existing data, the previous decisions that were taken as labels, and can you just train a model, a classification model, a supervised learning model to do this? So that is a question that I asked my students, the managers, the managers at that time. Okay. So one thing you have to remember is that when you do training, the training data is very important. If the training data is garbage, the insight that will come out is garbage. Garbage in, garbage out. So that is this thing that I wrote here, GIGO, garbage in, garbage out. Okay, the models are only as good as the training data. Okay, so now classification was into different classes. So the prediction was into discrete classes, discrete numbers. But if you're actually trying to predict a continuous number, okay, then it's called a regression. So if you have trends in the past, like say stock market price of the share price of a particular index or a particular company, and you want to know what is going to cost in the, or how much it's going to be in the future, that would be a regression analysis, time series regression analysis. Okay, don't try this because it never works. The regression analysis will never give you a predicted stock market price. You will be disappointed. Okay, but you can use it for cash flow in businesses, revenue, cash flow analysis. You know, if you know that a company was making 1 million, 1.2 million, 1.5 million, 1.7 million in the last few years, how much is it going to make next year is a fairly straightforward linear regression analysis. Okay, well, it's not limited to just time series data. One example that is in the standard data set is used car pricing using variables like mileage, the age of the car, the new car price of the same model, etc., etc. That would be a linear regression, multiple linear regression. Okay, so I have, in my class, I had 130 students. So I collected data from them some time ago to do some kind of research project. So this is the data I collected. I have the weight and height of people, and I had a distribution like this. So this is weight versus height. Okay, I have the height in the x-axis in centimeter and weight in the y-axis in kilogram. So that you can see that there is something like a line. So you can use that. If somebody else comes with a height of 190, the most likely weight is going to be something a little below 80. So this is the kind of analysis you can do. If you can add more variables, then it becomes this is a two-dimensional analysis. It could be three-dimensional or even multi-dimensional beyond that. In this particular case, just for the heck of it, you can see two different groups roughly. There are some people with heights say around 160 with weights like 50 to 55 or so. There's one group of people. Another group of people with height around say 175, 180 or so, with weight probably around say 70 kilos or 71 kilos or something like that. So what are these two groups? If you throw this data to a clustering algorithm, k-means clustering for instance, and ask it to create two groups, it'll actually create those two groups. And you can see immediately that one is would be boys, the other one would be girls. Okay, so that's what's going on here. Girls tend to be shorter and lighter, and guys tend to be taller and heavier. There's one guy here at a height of 170, so a bit shorter than average, but quite a bit heavier than average, 80, so an outlier there. Do you know who that is? Well, that was me actually, because I put my data also in the same data set. All right, moving on. Okay, so this is what we did. We looked at machine learning algorithms as like a bird's eye view overview, and we said that they could be divided into two kinds, unsupervised or supervised. Unsupervised would be pattern discovery. That would be algorithms like clustering or associations mining. In clustering, you had k-means clustering, hierarchical. These are the buzzwords you might have to remember if you are not a data scientist, but a manager managing data science kind of projects. Supervised would be classification or regression. In regression, you have auto regression or linear regression or multiple linear regression, etc., etc. So that is That is the overview of different machine learning algorithms. So I called it the biggest of big data, text data. Well, technically it's not big in terms of volume, but it's big in terms of information density. Okay, if you have a statement like Manoj is talking, that actually paints a picture that contains quite a bit of information. But if you want to show that in video, that will take this little video that you're seeing, that will take quite a bit of bytes. So the density of information in text data is quite high. In that sense, text data is big. So that's my justification of calling it the biggest of big data. Okay, text analytics. All right. So the problem with big data or text analytics per se is the fact that it's unstructured. There's no structure to it. It could be small body of text, huge body of text. It's not in a table format, and it's got meaning. Okay. So if you want to use it, there are avenues where business questions can be answered using it. So if you want to answer a particular business question, that will be like getting information out of a body of text, so multiple bodies of text, getting the most relevant document, etc. That would be information retrieval. Okay. And there could be sentiment analysis. You could have, for instance, people talking about your company or your brand online. Okay. And if you have data in text format, you might want to create data tables out of it. Okay. That would be generating structured data. And then topic discovery would be another thing. If you have a lot of tweets or a lot of text documents, what is it that they're talking about? What are the dominant topics in the text? That will be of interest. Okay. All right. So where do you get the text from? Usually from social media kind of analysis or from web scraping. Okay. So the question is, where do you get the data from, and what do you do with it when you get the data? Okay. So text analytics is not the same as data mining, because text is a different kind of data. The idea is to derive high quality information from text. High quality information, that's my buzzword, and I'll tell you what I mean by it in the next few slides. Okay. All right. So it actually lies in the intersection of getting the information retrieval, NLP, natural language processing, which is like computational linguistics, and then data mining, which will be the tools that are used on data, not on text per se, but on data. Okay. And in order to actually process text, once it is represented in some kind of a mathematical form like a vector, then you use machine learning techniques or statistics. Okay. So high quality information. Suppose you get some text like this. You're a busy person. You don't have time to sit around and read the whole thing. But a computer can read this in a couple of milliseconds and generate a summary. That would be a task by a smart text mining program. That is concise summaries, readable concise summaries based on text. That is what you have in the amber box there is high quality information based on the blue box. Okay, concise summaries. Another one, suppose you have some information that you scraped about Facebook and Twitter, some details about where they are and when they started, etc. You might want to put that in a database or in a table so that you can do further analysis. Creating that structured data out of unstructured text would be creating or generating high quality information. That's another one. Another question, suppose I told you earlier today that SMU has 6 schools, but suppose you didn't hear it and you want to find out how many it has, and then you go and look in Wikipedia, you get all the text there, and you want to read all those things to figure out how many schools, how many departments we have. And a text analytics program can actually locate the information and answer the question saying SME has 6 schools. That would be high quality information. Okay, exact answers based on text document. So it's very high quality information because only one statement saying, or just one number saying 6, that is the answer, but it comes from a body of text. Not easy to locate by human beings, but very easy to actually locate by a smart text analytics program. Okay, sentiment analysis is another one. This is about some restaurants, positive or negative sentiments, and why. Okay, that is again, sentiment would be another high quality text information. Now, so those are the application areas of this. and I'm actually going to teach text analytics next term as an elective for I think later years of information system students. And then some of these slides are actually from those things I'm preparing now. Language understanding is not easy even for human beings, but is really terrible for computers. Okay, first of all, we have to even say what we mean by meaning. Okay, so we have to translate each word into a number and say that, okay, these numbers mean the same thing, even though we may not be able to actually say what the meaning is. Okay, all right. So what's the problem with that? There's ambiguity everywhere. Suppose somebody comes and says he has an apple. What does that mean? I have an apple, but that is my Apple computer. Somebody else might have an apple because that is apple, the fruit. She has an orange and he has an apple. That's one way of looking at apple. She has a PC and he has an apple is another way of looking at the same word. That is lexical ambiguity. Okay, then there is syntactic, that is the structure or grammatical ambiguity. If I come and say Sammy ate cookies on the floor, what does that mean? Okay, it could mean that Sammy is actually picking up cookies from the floor and eating, or he's sitting on the floor and eating. Okay, the question is, who is on the floor, or what is on the floor? Is it the cookies or is it Sammy? Okay, that is called prepositional phrase attachment. On the floor, does that attach to the word ate or does that attach to cookies? That is an ambiguity. That is a structural syntactic kind of an ambiguity. And there is semantic ambiguity. Ambiguity is related to the meaning. So if I say something like Nick met Nat in the lift lobby and then they went to his house, his, what does it mean? What's the meaning? What's the semantic significance of the pronoun his? Does it attach to Nick or Nat? So that is another kind of ambiguity. There's co-reference resolution that needs to be done. All these things are from natural language processing or computational linguistics. There are solutions for this with varying degrees of success. Okay, one more kind of ambiguity in the English language. If you have kind of ambiguity based dialects of English. If you go to the UK, you have one set of words with the exact same meaning. You have a different set of words in the US. Lift versus elevator, petrol versus gas or gasoline, flat versus apartment, etc., etc. Okay, then there is sentence level ambiguities coming from synonyms. For instance, there are two sentences here. He was saddened by the news depressed him. The sentences mean the same thing, but they look like completely different kinds of sentences. Okay, or different meanings. So there are problems like this. That's why natural language processing, which is actually a precursor or preprocessor to text mining, is quite hard. Okay, so text summarization is a potential application. Information extraction, unstructured data, text to structured data tables. Question answering, that would be another use or application of text analytics. Sentiment analysis or opinion mining, and topic modeling. These are the different things that we can do with text analytics. Okay. So why do we want to do text analytics? Because copious amounts of data is being generated by customers, not just in terms of blogs and or tweets, etc. Also reports, business data, and also most importantly, customer data in terms of customer calls. Okay, actual real audio calls can be transcribed to words and text by machines and can be used with text mining algorithm. Actually, it's actually being done even when you're doing voice searches on YouTube or on your Siri. It's not just trying to understand what you're saying, but it's also trying to understand the context so that it gives you the right kind of, it picks out the right kind of words to answer. One important thing is that reviews and complaints are first logged in on the social media. So that is important. If you want to make sure that your brand is well respected, you have to make sure that the reviews and opinions and the tweets are all well respected. Otherwise, it will really affect your bottom line. and reviews and tweets all have tangible impact on your bottom line. Okay, basically because brand lives online these days. Okay, really, when I want to buy something, I go and look at reviews. I don't really look at product reviews or product publicity kind of pages, but I look at people consumer reviews. Even those are being influenced by nefarious means these days. Okay. All right. So there are questions like customer service calls, audios. Can it be transcribed to text? And could you figure out where the bugs are using the textual data? Okay. Not really debugging the program, but by looking at the textual data, using text mining on the data, can you figure out what features will need more work? Okay. Or bug fixing really. And then the next question I was asking is, if you have images and video, can you figure out there are bad placements for your brand? Okay, again, a business question. Again, we may not be able to sit through all the video or look through all the images, but a computer can do it in a fairly reasonable amount of time. Okay. So that's where text analytics comes in. What I'm trying to say is that other forms of big data, like images and videos and audio, can actually become text and drive into a text analytics program to derive business value. So that's what I wanted to say. So that brings me to the end of my talk. I just have this slide to wrap it here. Okay. So I talked about the four pillars of four megatrends of the changes in the data landscape. On the supply side, how the data is being created, the huge volume, the explosion of data, and the demand side, the pull side of data, the requirements, the service and improvements and new business models, etc. And also the velocity requirement, how and why people require immediate, instantaneous, real-time insights being generated. That can be done only by data analytics. I forgot to mention that. You cannot have a human being generating real-time insights because it takes time for a person to do it. But if it is deployed in an automated setting, data analytics can actually generate automated insights. And all these things are standing on top of technology innovations on the hardware space as well as software space. Okay. We talked about the megatrends in the data, and then we talked about data analytics. Data analytics really is about automated generation of insights. Okay. Real-time insight generation. All right. And we talked about different tools and algorithms that we have in data analytics with the view to informing you about the right tool for the right kind of question. Okay. If you have the right tool, you get the right answer to the question asked, but the question also has to be right. Okay. So that is important. You have to have the right question to get the right answer. If you have the wrong question, the answer is wrong. If you have the wrong tool, the answer is wrong. So you have to get everything right. So that is kind of all I wanted to say. The last topic was text analytics, and I think it is not being harnessed to the extent it could be. And I have this warning: ignore it at your peril. By your, I mean your business. Okay, if you ignore it, it may not be the right thing from the perspective of the bottom line. So that brings me to the end of this session.